I'm going to introduce something known as an energy bar chart, and it's really just a tool for you to be able to look at a problem, use it, and then help you identify what type of energy is at each part of a problem. And this is especially helpful when you're looking at something that has maybe more than two parts. But to introduce it, we're going to start just by looking at what an energy bar chart is, what it looks like for a single object doing a single thing, and then we'll start looking at what it looks like for more than one thing. So they qualitatively show what type of energy is in each part of a problem. Qualitatively means you're not calculating anything, you're just essentially making a bar graph. The height of the bars does not matter as long as total height between the charts stays the same. If there is more than one type of energy, the height of each bar added must equal the same as the total. Like I said, this will make more sense once I actually do it. So for number one, a ball rolls on a level surface. All you're doing is looking at the problem, looking at the object, and asking yourself, what type of energy does it have? It's rolling on a level surface. There is no change in height, but it does have motion. Therefore, all of the ball's energy is kinetic. Like I said, it doesn't matter how high you go. I'm just picking 4. I tend to shade it in just for aesthetics. You don't need to do that. So what this is showing is that that ball has all kinetic energy. There's nothing else happening, so there's no gravitational potential energy. The next one, we have a ball at rest on a table, and the picture shows us that the height is 0 on the floor. So that means height equals 0 is your base level. Since the ball is not moving, it has no kinetic energy. It does have height. It's above the table, so it's going to have gravitational potential energy. And just to prove that the height of the bars does not matter, it does not matter how high you choose to go, I'm only going to go up 2 lines this time. The bulk of our problems are going to be looking at 2 different things happening to the same object and showing the energy bar charts between A and B. And really what this is going to do is lead us into solving, so actually being able to use the equations and solve for something like speed or height. So we have bar chart for A and the bar chart for B. If you look at A, the pendulum is above the base level, so it tells us height equals 0. Remember, that is your base level. So it tells us at A, it's above the base level, but it's not going to move. So at A, it's going to be at rest, because that's right before it starts swinging. So it has no kinetic energy and all gravitational potential energy at A. Once it gets to B, the pendulum is swinging, it's at the base level, and it's moving. So it no longer has gravitational potential energy. All that gravitational potential energy became kinetic energy. And this is the only thing that matters when it comes to height for bar charts. If I have a bar that is 3 lines high in A, it needs to be 3 lines high in B. All I'm showing is that all of this energy at A became the same amount of energy at B. Okay, the next one, we have a moving cart coming to rest at B. So at A, it's moving, and it's at the base level. So again, make the ground your base level. So at A, it's all kinetic energy. At B, it comes to rest, like it tells us it comes to rest at B. So it's no longer moving, but it has gravitational potential energy. So showing that all of my energy at A became all of my energy at B. And then the final example, already in motion, a cart rolls up a hill. So if you look at this one, it's different than the one before because this one is moving and it also has height. So we're going to make the ground the base level once again. At A, it's moving. At B, it has both types of energy. So it's moving and it has height. All I need to be careful of is that I went 3 lines high here. 1 line plus 2 line is 3 lines. So the total amount of energy we have here has to equal the total amount of energy we have there. And that's it for the bar charts. So it's just a representation to show how much energy you have at different points and what type of energy that is. And like I said, we're going to use those when it comes to actually solving. They're just a helpful tool to get you to visualize what's going on in the problem.